There we go. Ready when you are.
Thank you very much, Bella, and thank you, a big thank you to the University of Canterbury for giving us the opportunity to present today to the students of the university career pathways with Costello. I am Nick Varugness. I am the engineering manager of the Costello Crisis Office for the last 4 years, and I'm a chartered professional engineer. I'm practicing in the geotechnical field. And today I will give you a few presentations together with two senior structural chartered professional engineers that each one will present to you different topics. One will be Paul Ferguson, CPENS, and he will give you a presentation about structural engineering pathways with Costello, and Aidan Quinn, a chartered professional engineer with the Institution of Engineers Ireland on engineering and insurance. But we will also have the opportunity to have to see a lot of different things with the other disciplines that we also offer at Costello. So before we start, let's have a look first on the outline of today's event and the presentations that you will have the opportunity to watch and hear. First, we would like to start with a video that we have from a recent project that Costello was involved, called The Landing, which is based in Marsden in Northland. Then we will move on to have a brief look to the Costello capability statement. And then I will give you a presentation on achieving a sustainable career in engineering with Costello. Then we will have the opportunity to have another presentation by Paul Ferguson. As I told earlier, Paul is a structural CPENS engineer that he will talk about the structural engineering pathways with Costello. And then we will have Aidan Quinn, who will talk for engineering and insurance. And then I will give you some quick presentation on the architectural pathway that we have available at Costello, and then a little bit more detailed presentation on the geotechnical engineering pathway, a very brief presentation on engineering geophysics, and we will close the session with any questions you may have, questions and answers session. We will start then from a video called The Landing Project, just to give you a little basic information for this project. It is a 440 lot subdivision in Northland. Currently is at stage 3, and basically there is earthworks. We move 20 to 40,000 cubes of organic material per month, and we do a lot of currently site testing with one company that we have as a sister company called GeoCivil. We will have the opportunity to explain all of these things to you. So let's start with the video first, and I'll see you again for the first presentation. Okay. I hope you the sound and in general, you know, the resolution was good for you to watch. Now we go back to the presentation. So I would like to ask Aidan to join us and say a few things about the capability statement that for Costello. Aidan, will you be able to join us?
Yeah, not too bad, folks. Hope you're well. Generally, it is what it says on the tin here. We have a company that was established originally back in Whangarei. It was Mr. Cook back at the time, and it's now his son that is the director and wife. So it's very much a family firm. It's grown over the past number of years to have branches now from Whangarei to Auckland to Wellington and Christchurch. And as you see, there's an extensive list there of services that we provide. We're quite proud of the fact that not only do we, I suppose, come across it being a jack of all trades, but actually we are masters of a number of them, especially our structural and geotechnical, I suppose, expertise. We have a sister company in Geocivil that perform in the capacity of experts in testing matters in geotechnical lab facilities, based here in Christchurch and also up in Auckland, and then further afield, actually down in Queenstown more recently. And so we have a national capacity there to, I suppose, serve the needs of the wider national New Zealand country. And so, yeah, I suppose after the presentation today, you'll have a better idea of what we can provide to our clients and where hopefully maybe you fit into the services that we're provide in the future. So yeah, I'll hand back to Nick, and I suppose we'll get the ball rolling here.
Aidan, as we said earlier, then in our presentation, we'll now move to, as we said earlier in the introduction of what we're gonna discuss and present to you today. The first presentation is about mobility of global engineers and achieving a sustainable career in engineering with Costello. Basically, the presentation which we have prepared for you is about you. It's about the graduates or even the current students, which we know that some of you have started, you know, asking questions to you. What is next for me after graduation? How will I get work? Or even some of you may even think, how will I establish my own firm, consultancy, contracting company? Am I prepared to work for others or for myself? How will I attract the attention of recruiters or bigger companies? Or how will I attract clients? Am I targeting the correct market? You know, in order to help you to somehow answer those questions, we prepared a small presentation divided in two parts. The first part is we'll discuss about chartership and how to obtain chartership status and why. And the part two is what Costello can offer to graduates. The first part, we start from that, is about how to obtain chartership status and why bother to do that. We came up with an advice to the students and the graduates or the young engineers. And the advice means that you can follow or you simply don't. And the advice is to become a chartered engineer with at least one institution that offers global qualifications, like, for example, Washington Accord. So basically, your qualifications are a member of broader international qualifications under the Washington Accord. Such qualifications can be found from the IC Institution of Civil Engineers, Engineers Ireland, Engineering New Zealand, and so many other institutions across the world that they have signed international agreements. So, yeah, this sounds a legitimate advice and a good advice. But if that is the objective, how can this be fulfilled? What does it require from you to do? Basically, in order to become a chartered engineer, will require from you structured learning and work beyond and after your graduation, which means basically you need to adopt a lifelong learning mentality or continuous professional development mentality. Basically, you are entering a profession which requires you to somehow dedicate your time and yourself to lifelong learning mentality. There are some agreements which are massive tools for the mobility of engineers. These 3 agreements are called the Accords, and they have the names of Washington, Sydney, and Dublin Accord. And through those agreements and beyond that, the values that we want those that have these qualifications from those agreements, the next step is to make them chartered engineers. And the chartered engineers have some global values. These global values or qualities are basically around to have some technical knowledge, to be able to do problem solving, to understand well health and safety, to be able to manage others and resources and tools, to be responsible for your own work, to communicate well, effectively, to use relevant codes, and so many other things that make together a nice puzzle of chartered engineer. So, and now, of course, the chartered engineers are looking into the sustainability for many years, not just for now. We try to tackle the climate change. So, basically, you by becoming a chartered engineer, you are preparing yourself to be able to operate your own business successfully. And if you can demonstrate that your experiences of a chartership level, you will at least be attractive as a candidate to engineering consultancies. But the thing is that how can you reach the experience and the continuous professional development to demonstrate that you deserve chartership? Here, you could have a catch-22 situation, you know, because if you don't have the experience, you won't be becoming chartered and so forth. So how do you get the experience to become chartered, and how much time, effort do you need for that? So the answer is that you need to plan your learning and your career. And the answer to this problem is that the consultancy that you will work, even if it is yours, even if for someone else, you need to invest your own development to CPD, continuous professional development. That means that you need to dedicate your time, but at the same time, the company you work for needs to develop. Basically, it's a 50-50% responsibility to both these bodies, if you like to call them like this. So if you meet those 2 above constraints, then the requirements that fulfill success can be met, and then you can become chartered. So basically, you need either to find a way of working for a company that will develop yourself, or either you have to do it yourself. Now, how will you become a chartered engineer? You know, okay, we want those values, those kind of stuff, but the big question is how. How do you program your CPD, and what does CPD mean? Well, CPD means basically you can take seminars, books, YouTube, webinars, you can engage in local engineering institutions, you can mentor people, others, you can choose a topic that you want to excel, you can give presentations, all of them count against your CPD. What are now the topics that you need to be able to work your CPD around? You know, what to choose. There is a certain variety of disciplines, if you like, or skills required. So one is the self-development, basically to develop your leadership skills, your decision-making, professional ethics, and rules of conduct can be some examples. Your communication is another skill set. How to report them, how to write letters, how to interview others, how to negotiate, how to manage meetings, all of those things, which sounds essential, but if you think that if you now start thinking that you need all of this together, it's substantial work that is required from you. Or strategic management, for example, to develop business plans, you know, for the company that you will be working, or health and safety legislation, policies and procedures, quality assurance and quality management. Another area is special interest that you need to decide what are you going to be, a specialist in energy, ground, maritime, transport, water, you need an area. And in general, what we want to tell you is that you need to be prepared, prepare yourself for international and national career. New Zealand offers that you fulfill both requirements by graduating from the university. And what we try to tell you is that as a company, we think with both national terms and international terms, you should do the same. If you prepare yourself with chartership values, you will have transferable skills to other countries. Engineers usually need to go around the world because they have challenges or nice projects of work. And you also will be good to choose a field for you to excel, usually geotechnical, structural, civil, or earthquake. That was part one around, you know, chartership values in general. But what can we offer to graduates? So basically around these lines that we have from Engineering New Zealand and the general chartership values across the world, we make our best effort to plan your development around those things. We run an internal continuous training program for mentoring graduates. We offer training in a structured way. We prepare you for becoming CPENs. We work in alignment with Engineering New Zealand mentality, and we give opportunities for innovation. Innovation maybe is a big word, but we believe that we also try to do some novelty things with Costello, so we can develop new products or services or design. We also can give you the opportunity to go to conferences or publish papers and publications, which we have produced 18 such papers in the last 6 years in geotechnical, earthquake, civil engineering that have been peer-reviewed in local and international conferences, and we have provided methods to industry that our colleagues trust to use. And basically, as you understand, we're a multidisciplinary consultancy and design services company. We do civil and related infrastructure, structural engineering and earthquake engineering, surveying and land development, geotechnical engineering and geophysics, project management, architectural design, and we're offering also accredited laboratory testing via our sister company, GeoCivil. We have been operating for the last 40 years, and we currently operate from Christchurch, Wellington, Whangarei, and Auckland, and we have about 60 employees from 13 countries. And the sectors we work in are insurance, QC, private, commercial, research, city councils, NZTA, Wakakotahi, district councils, and Kaingaora. And how can we support you? We have teams of 3 to 5 engineers. As I said, we have an internal continuous training program for mentoring graduates. We have a team leader who is a CPENs or near CPENs that offers the mentoring and technical support. And you will have the opportunity to have project ownership and working in-house with other disciplines. If you want to apply for any given time for any type of roles we have available, you usually interviewed by one of our senior engineers and the engineering manager of the respective office. And you may be asked a few technical questions, but we are more focusing on your strength and your specialization. And we focus also on your character, be able to communicate, be collaborative, be able to work in a team, be ethical and honest, things like this, you know. We have here for you just a sample of a few papers we have published, and we have published with the New Zealand Geotechnical Society, under the CE, with CSOC, with New Zealand Geomechanics News, and other international conferences. So that is the end of the first part of the presentation. And now I will pass it to Paul to present us the next presentation. Paul?
Yes, hello everyone. My name is Paul Ferguson. I'm a chartered engineer with Costello. I'll talk to you a little bit about our structural engineering team nationwide and sort of the path, the career path that one could have with a structural engineer with Costello. So maybe just pass on the next slide if you don't mind, Nick. I've only got a couple of slides to go through, but I'll do plenty of chatting in the meantime. So just to give you a little bit of an idea of the size of the organization, we've got around 60 or so staff between 4 offices. We're based in Whangarei, Auckland, Wellington and Christchurch. So we actually have a huge diversity and we've got huge diversity in terms of collaborating with the other disciplines, including geotechnical, geophysics, architecture, civil, and so on. And now most of our calculations historically have been paper-based calculations. So we'd typically be going to the standards like 3604 or the New Zealand concrete masonry standard or whatever, and looking at different charts and manually printing things out and photocopying and so on, and actually doing hand calculations with calculators, etc. But more and more, we're changing towards spreadsheets and software. So we do that for all of our so-called bread and butter projects, the ones that pay the bills, so to speak. So within that, we typically have residential projects where we deal with roofs and canopies. We do bracing analyses. We design beams and balconies. We design foundations, which can often be quite tricky. You know, we deal with slabs, piles, subfloor braces, all of that sort of thing. We also deal with commercial projects, so warehouses or industrial units or multi-story blocks. Typically we end up dealing with portal frames or tilt panels when we're dealing with that type of building. We also do structural assessments. So that is assessments on existing buildings that are suspect for some reason, perhaps post-earthquake or perhaps mid-appearance of a fresh crack or something along those lines. We do insurance-related assessments, and we do some difficult projects that involve alterations of or extensions to existing buildings, often multi-story. Being a medium-sized company and a nationwide company, we have quite a lot of diversity in terms of projects. So when we're dealing with geotechnical aspects, so there's a lot of overlap between structural and geotechnical when it comes to foundation design. And we deal with projects all over the country. So we learn about expansive soils in Northlands, for example, or liquefiable soils in Christchurch, or drilling into grey rocky rock in Wellington, for example. And we also deal with some civil work. So often we have to coordinate things with the civil engineers, like, you know, avoiding pipes in the ground, having buoyancy issues, for example. And we also have quite a diverse range of people, as you can imagine, spread over those offices. So it's not that 2/3 of the company is Irish, as you might gain from my accent and Aidan's accent. Yeah, we have some locals, don't worry, as well. And we also have a range of unusual projects. So we can deal with projects that are small, medium, or large. And sometimes we deal with the projects that are very small, as in they might be design of temporary structures, such as temporary platforms or cranes, or scaffolding units, or temporary props for the tilt panels, that sort of thing. We also deal with shop fit outs quite a lot. So that is the design of seismic supports to non-structural elements. So that would be things like extraction hoods in restaurants, and then suspended ceilings in offices, and then things like, you know, large signs appended to a building, whatever. We deal with things like guardrails in Wellington, especially, where we have a lot of projects on hillsides, and we have to avoid the situation whereby a car can career off over a deck or whatever down into a hill. We deal with a lot of retaining walls, sometimes on very steep sections, sometimes lots of challenging areas. We do slope stability analyses as well. We deal with things like tall chimneys, and we deal with things like large signs. So if you moved on to the next slide, please, Nick. So this is an example of one of the large signs that we dealt with down in Christchurch. So we typically get something like the drawing on the left, which is sort of schematic drawing of what the sign owner thinks the end product will be like. And then we model it, including something like the foundation, which is the part shown in green in the middle. And we add in whatever wind loads, etc. So these tend to be wind sensitive structures, and hence we have to go that extra mile to find out their natural frequency, etc. And then in this particular case, we modeled the supports of the foundations as if they were springs in the soil. So we analyze the soil and find out what we think is a suitable range of numbers for that. Just move on to the next slide then, Nick. And we also deal with, in that particular case, we had to look at fatigue failure. So a lot of the detailing around that particular sign came down to the idea that if it bends back and forth from wind loads over the course of the next 50 years, if it does that multiple cycles, like millions of cycles, it could actually fail in fatigue failure. So had to go to the extent of figuring out stresses on wells and bolts, etc., and making sure that they were low enough stresses that they could last up to a design life. So we ended up designing them for 160 or so years on the left. So we have huge diversity would be the message. Just on to the last slide then, Nick, please, from me. Occasionally we get some quite unusual projects. So this is a residential project whereby client wanted to create a house using box culverts. So these are box culverts that are typically 6 or so meters wide, 2.4 meters tall, 1.2 meters deep, that sort of range. And ordinarily they're buried in the ground, and they're buried in the ground in valleys designed to take large volumes of water to a stormwater system. But in this case, someone wanted to create a residential house out of them. So structurally speaking, it was quite unusual. It happened to be sat on some expansive soil up in Northlands. Now it turned out to be a bit of an architectural nightmare. So we had to coordinate with the architects to make sure that we were able to waterproof everything and get the correct amount of insulation, and also make the thing look aesthetically pleasing, and then do things like there were some internal timber framed walls in that building. We had to do things like try and hide all of the plumbing and electrical wires, etc., in those sort of walls. So yeah, we're just the right sized company for quirky, unusual projects like that. Okay, that's it from myself, Nick. Thank you.
Thank you very much, Paul. And now, Aidan, I would like to ask you, to give your presentation and around what is it all about, engineering and insurance.
Yeah, my name is Aidan Quinn. I am originally from Ireland, where I studied in Queen's University Belfast. I graduated there with a master's in structural engineering with architecture back in 2011. So I worked in Ireland for just over 3 years before coming to New Zealand, and it was actually with Costello then that I gained my chartership back in 2019. So that leaves me today that I'm currently leading the insurance team in Costello. And so I say that sometimes to people and they're not exactly sure what that means. So what exactly is it? So yeah, natural disasters and hazards and risks. I suppose the last 2 decades have been quite a busy time for natural hazards in New Zealand. We have had our fair share of storms and floods and landslides, not to mention earthquakes. And some of these hazards have obviously resulted in damage to our homes and our land. Through the Earthquake Commission's natural disaster insurance cover and private insurance, people have a chance to get back on their feet, I suppose, after a significant event has occurred. People automatically have what's became known as EQ cover for their homes and their land if they have a current private insurance policy for their home that includes fire, and generally most of all policies do. EQ cover then provides insurance for damage from many different natural hazard types. So it's not just earthquakes we're talking about, you're talking natural landslips, volcanic eruptions, hydrothermal activity, tsunamis, and it's just about all of the big and bad that Mother Nature can offer. And so the next slide, Nick, yep. Costello's history and involvement to date in these events have been quite extensive. We can quite confidently say now that Costello is firmly established as one of the industry experts in natural disaster event recovery, particularly in the field of assessment and repair of earthquake damage, and that's across a range of engineering disciplines, not just structure. We have been integrally involved, I suppose, in the Canterbury earthquake recovery and all the subsequent natural disaster events since 2010. We've provided expert technical advice to private insurers and to the Earthquake Commission and to homeowners alike. Jump to the next slide, please, Nick. So I suppose, yeah, natural disasters can cause all sorts of damage to the built environment, and the various stakeholders whose responsibility it is, I suppose, to fix that damage, they rely on engineers to be able to assess it and repair it correctly. Insurance-related work is quite specialized in that regard, and it requires not only, I suppose, technical engineering knowledge, but also a working knowledge of insurance policies, the EQC Act and all the legislation that goes along with it, and even the development of, I suppose, legal case law. Engineers have to have a working knowledge of it all. The projects come in all different shapes and sizes and complexity, and from a range of different clients with different, I suppose, interests in that regard. Currently, we are in now a time that the insurance industry in New Zealand generally refers to as peacetime. Strangely enough, considering everything that's going on in the world, but it refers to a period of time in which we're in a state of, I suppose, relative non-emergency. Today, I generally consider our work in the insurance team then to be categorized into 3 main, I suppose, subcategories. The first one would be legacy or ongoing claims and reinsurance advice. So we're talking about historical events such as Canterbury earthquakes and the Whangarei Kikora earthquake, which are still very much present today, all in various forms. And then we'd have new claims, just as I said before. Look, natural disasters are part of New Zealand's DNA, and events are occurring all the time at various levels. Even today, I suppose there's a significant event ongoing just up in the northeast with severe flooding, and yeah, it all needs to be addressed. And the third then category would be readiness and resilience, and so that's essentially just planning for the future. Nick has scooted on already, so yeah, the slides are good. I don't know if that's doing that automatically, but so what exactly do these stakeholders want from engineers, and how do we do it? Is really the main question. the assessment and repair of damage is, as I was saying, a very specialized skill and contains a body of knowledge which is kind of growing all the time. The level of investigation into and detail, I suppose, into Canterbury homes is on a level I really never would have imagined before coming to New Zealand. Costello offers an extensive list then of services to stakeholders to try and fulfil those demands. This includes everything from the initial emergency reconnaissance effort. And so if you consider Kikora, it was as early as the next day that staff from Costello were in helicopters, I suppose, surveying the land, surveying where the damage was and the most, I suppose, severely hit areas actually were. And then it goes all the way through to just structural and geotechnical services, including we have our internationally accredited testing lab, and then we have surveying and geophysics and architectural services, project management, software development. But that all comes together in I suppose, a combined effort in our ability then to offer expert technical advice to support repairs, legal proceedings, reinsurance, and further research publication, and just generally the transfer of knowledge and new learnings. And so that's a long list of various services, but what does insurance work actually look like today currently, and what I suppose are those stakeholders really looking for? Simply put, the two big questions our clients are asking, or what they want answers to, is one, look, is it damaged by the natural disaster? And two, how do we fix it? It's I suppose as simple as that, maybe they'd say. And so how do we actually do that? It's forensic, structural and geotechnical residential assessments that help us form those answers, and they're essentially the bread and butter of what we currently do in the insurance thing. And so forensic assessment, it's quite a fancy word and it may seem quite straightforward, but it's the case that I suppose there's unresolved earthquake claims that have been ending up as the subject of countless high court claims over this past 10 years. Generally speaking, earthquakes have two main damage causing mechanisms. So damage from high intensity shaking and damage from settlement, typically as a result of liquefaction. So today, these same two questions still need answered for a host of ongoing claims. Sometimes damage has just went unnoticed for so long until a problem starts to surface. Sometimes previously repaired damage just hasn't been done properly, and the repairs have since failed. And it becomes a question of why and who's responsible. And again, that question of how do we fix it? And sometimes the various parties simply can't agree, and disputes go all the way to the High Court after long and arduous and I suppose expensive dispute resolution processes. For some of the more complex claims, accurate assessments require a combined effort then from a host of disciplines, but generally, as I say, we require structural and geotechnical experts, sometimes surveyors, and then regularly builders who provide a very valuable practical approach to the trades and those skills, I suppose, that sometimes are overlooked by engineers, to be perfectly honest. For ourselves then, I suppose the big focus that we have is on the soil structure interaction. It's essentially understanding how the building has performed, and it's a holistic understanding of these geotechnical and structural engineering principles and how they come together. It's something that we at Costello, I suppose, would put a great deal of importance on. There are a number of endless other complicating factors then too, and engineers in this field are becoming more and more akin to detectives these days, with the various sources of evidence all that have to be considered, especially after the passing of time, and it just becomes that much more difficult, I suppose. And the accurate identification of damage has become nearly a bigger part of the process than the actual repair itself. Some of the photos that were shown previously are just some of the methods and techniques that we use every day to assess buildings. So you're talking level surveys and wall verticality surveys, assessment of the functionality of fixtures and fittings, and interpretation of geotechnical data and ground conditions. And we have to have a consideration for historical alterations and renovations, for upstairs additions, for example, and kitchen upgrades, and all those things that I suppose come together to affect the overall building and superstructure. And then following that entire process of trying to identify the damage, we still have to then go and try to repair the damage, which brings its own complications. Repairs have to consider the existing built environment, which is a key component that sometimes is overlooked. If you go to design something new or build something new in that regard, you generally have a clean slate to work with. While there's the building code and we have the Building Act, essentially for those sorts of designs, there's not essentially a one-stop guide to engineering earthquake repairs, and so more often than not, things are less than straightforward. But yeah, so it's definitely interesting. But yeah, what's new? I suppose with all these experience and skills that I've been talking about here, there are new developments that are happening constantly. The most recent is what has been referred to as the NDRM. What does that mean? That is the new natural disaster response model. So as opposed to a development in technical knowledge, this is a change in operational frameworks and processes. Essentially, EQC have handed over the reins to the private insurers to manage the response to natural disasters going forward. With it has come the need for new specialised services and skills, which previously would have been held solely by EQC to an extent. The most prevalent of that probably being land damage assessment. Costello again are at the forefront of these developments, and we're working closely with both EQC and the private insurers to develop these processes from an engineering perspective, so to ensure that I suppose a comprehensive response can be delivered following a natural disaster. But you may wonder why such developments, I suppose, would concern engineers whenever it's, as I say, processes and frameworks of a sort. But more often than not, these changes, I suppose, in operation have a very real practical implication in how we do things and how we must adapt and grow as a company. This change highlights another fundamental part of engineering that's sometimes overlooked, which is essentially the business component of the engineering industry. It's simply another example of how we as engineers must have an appreciation for the business models for which we work in and the implication of everything from politics to the changing economy and all the other various facets of business. Technical engineering knowledge will only really take us so far, and then we have to be aware of the environment in which we practice. So you may all be thinking though, sorry, next slide, Nick. The Canterbury Earthquake series is done, and what's in the future? One of the core aspects of work as an engineer in the insurance industry is to reduce risk from natural hazards and build our resilience as a country. Costello have been instrumental in this role by providing advice through the years to EQC and the private insurers in the past. We developed a lot of the standardized protocols for assessment, which are used as best practice still to this day. And so our role has only really grown over time in the industry. And today we find ourselves on the short list of expert advisors and suppliers of services to EQC and private insurers. So recently, Costello have provided what is known as our CAT event response support plan. It's a bit of a mouthful, but it relates to catastrophic event scenarios. It's essentially planning for disaster. It's all about planning to have the necessary resources and specialist services in place to provide the appropriate response through all the stages of a disaster response for an event of almost every size. So you're talking everything from your typical earthquakes all the way through to volcanic eruptions and what that looks like. I personally have found it very interesting to be involved in matters of kind of really such significance and something that potentially will have a real and lasting effect for people in the future. A key part of that response model which we have put forward is indeed our recruitment plan. A key part of what we do relies on training and developing new engineers, new graduates in their respective roles to ensure that that specialized technical knowledge is maintained. And so we then can respond in an emergency event and do our part, I suppose. So Yeah, that's a general rundown of the insurance and engineering and how it all comes together and what our role in it all is. If it sounds like something you might be interested in, sure, I suppose maybe keep us in mind. But yeah, that's me for now. I'll hand back over to Nick. Cheers.
Thank you very much, Aidan, for the presentation, the information for the students and graduates. So we will move on to the next presentation we have prepared. It's coming from the architectural designer LBP that works with us at Costello, but unfortunately she's not able to join us today. So our architectural design prepared this, and I will give you a presentation, a quick rundown of the architectural design services and the LBP licensed builder practitioner pathway with Costello. Basically, we offer architectural design services, and we offer expertise in the residential new house designs, extensions, alterations, commercial design, home style assessments, which are used a lot for Whangarei and for social housing new developments, sustainable design and universal design. And the sectors we work and offer the services are insurance, EQC, private, commercial, district councils, and Whangarei. We have a small architectural team, and we offer the same support as we talked earlier about chartered professional engineers. LBP is a different scheme, but it is still a qualification, professional qualification, and we still support it the same way with continuous professional development at Costello. So we have a small architectural team. The same internal continuous training program is offered, where we have a team leader who is LBP Design 2. We offer technical support and mentoring from the LBP. And you will have the opportunity to have project ownership and work in-house with other disciplines like civil, geotech, structural, and so forth. We have accreditation from the New Zealand Green Building Council, and our designer is a Homestar assessor, and we're also accredited by LifeMark to offer sustainable and very practical applications for people who are in need, or they have some special requirements around architectural design for their space to be livable. Our mission is to provide sustainable and profitable business platform for a team of professional consultants in support of the individual career pursuits. So this is our mission as it is perceived by our architectural team at Costello. Now we can move on to the next presentation, which is about geotechnical engineering career pathway, which is one of the big, if you like, disciplines that we have available at Costello, as Aidan explained to you earlier about our insurance involvement. So the career pathway with Costello as an overview is very simple. You can be a student, become a graduate, then a professional, then as you accumulate more experience, you become a mentor. So we try to help you to go from being a student to become a mentor. How do we do that? If you were hired at Costello, the early days would be looking like that you will need to be involved in shallow investigations along with geocivil trained technicians. I remind you, Geocivil is our sister company, the INZ accredited soil testing laboratory that we have available. You can see here some photos of the equipment and some investigations plans. You will be involved, to classify and describe soils and behavior as you log them in the field, or as Geocivil logs them for you. And the reason is to produce some reports. And you can see there we use NZGS field guide sheet, and to the right you can see what we produce when we return to the office to make a report with all the data presented in a nice way. If you were hired and at Costello, your early days would be looking like you would need to undertake the commission and supervise deeper geotechnical investigations like core penetrometer tests or maybe some boreholes, and be involved in preparing geotechnical models, cross sections basically, either 2D or 3D with some software, and tried in an effort to visualize the variability in ground conditions, basically come up with the layers, thicknesses, and things like this. If you were working again early days at Costello, you would be involved to identify natural hazards by doing desktop studies, for example, looking at liquefaction, flooding, or undertake geotechnical analysis around liquefaction, how much sediment we could have at the site, or be involved in the foundation design and site characterization for projects, or you could be involved in communication and reporting with clients, or preparing reports, or even construction monitoring. So basically go to the site and undertake some tests or work with the contractors for making progress to the construction of the project. As we told you earlier, our sister company GeoCivil is an accredited laboratory, and you can see here some snapshots we have from our laboratory. So you can see on the right here a consolidometer under operation, and you can see here on the left some static plate load tests that we were doing for some projects down after the Kaikoura earthquake, and our own CPT rig that GeoCivil owns. And the last presentation for today will be a very brief introduction to engineering geophysics. Just to remind you that we offer geophysics, and the geophysics is part of our geotechnical services. So the geophysical team we have operates as a part of the geotechnical team. And basically, why are we doing that? We're doing that because there are several ways to investigate what lies underground. You can do excavation, so you can take materials out of the earth. It's going to cost you some money. You can do drilling, it's going to cost you some other amount of money. And you can use geophysics, and it will cost you another amount of money. Usually, if you can see the relation of volume between the three, is that in the excavation, it costs a lot to excavate for the whole site and check the soils present there. Drilling costs even too much because it is an expensive exercise. And geophysics, as you can see from comparing with drilling, you can see that it offers, and we'll see that it offers more volume information, which is more volume specific rather than point specific in comparison with drilling. There is a saying, which is very correct, that says, you know, the site investigation finishes with the excavation of the soils, and only then. So when you do site investigation, it's very difficult to go and do a huge excavation, you know, for the whole site. That's where we need to consider the economy of the site, and that's where geophysics come into place. So geophysics is something which is not new. Basically, geophysics is responsible for the world we are living today. It is responsible for having oil products like plastic and tires and so forth, and is responsible for basically being able ourselves to have cars and mobilize them, because all these deposits are found by geophysics. Otherwise, it would be very, very difficult to drill so many unsuccessful boreholes all over the world. So geophysics has families of methods like the electrical resistivity methods, the electromagnetic methods, the potential field methods, the nuclear or the seismic methods. The resistivity methods, they use, we have the electrical resistivity tomography, RT, or the self-potential, or IP, induced polarization. In the electromagnetic methods, we have the ground penetrating radar, or GPR, we have metal detectors, we have the VLF, very low frequency methods. In the potential field methods, we measure the intensity of fields like the magnetic or the gravimetric gravity. In the seismic methods, we use reflection or refraction methods, which are surface methods, or we can use borehole seismics, much more expensive, downhole or crosshole, shear wave or primary wave, or we use nuclear methods like NMR, nuclear material resonance. But where and when do we use them? We use them, for example, to find the geology, the type and the lateral and vertical variations on a site, where the groundwater is, for example, exploration and contamination mapping, for geohazards, for earthquake mitigation and collapse structure mapping, for infrastructure like highways, bridges, and so forth, for urban reasons like underground storage tank locations, for landfill investigations, for archaeology, and for unexploded bombs, basically to find UXO detection and characterization. But what is geophysics and how does it work? Basically, it works by going after some physical properties in the mass of the Earth and trying to find contrast between those physical properties. And we usually do that by emitting a signal. The signal can be electrical, acoustic, magnetic. We expect to receive a response signal back to the surface. For example, we can have different arrangements of resistivities. We can have high resistivities and then lower or the opposite, and this can be interpreted accordingly by processing the data in order to obtain geophysical models. And then we compare them usually with existing site investigation in order to make them meaningful. So why would we use geophysics? Suppose you have a site and you do a borehole and you come up that you have a dry sandy gravel, a saturated sand and clay as a layer thickness and layer sequence. If you only do that, you only know that specific location. But if you are involving, for example, resistivity methods, you are able to delineate by measuring the resistivity what are the probable extension lateral and vertical of those deposits beyond the borehole. So you can find out the dry sandy gravel, the saturated sand and the clay, and how the layers are becoming thinner or thicker across the length or width. So we have here a case where you can see that for exactly the same site, 500 by 200 meter, a scenario by having CPTs, hand doggers, and a machine borehole combined together as an option would need $13,000. But if you do another option, it would cost you $15,000, and you will have 2,000 times more information, because there you check the volume of the soil rather than just the specific points. And you can see with the $15,000 option, you minimize the number of boreholes to a smaller number of boreholes, intrusive investigations combined with more geophysical testing. Of course, there's no one answer to that. This is called optimization. We need to find what's the best scenario, and that's what we try to do by using geophysics in our project. So when we prepare proposals like this, we consider the anticipated physical contrast, because that dictates the appropriate method, and that's why we have a team of dedicated geophysicists. We look into what geology we have, the depth and the size of the targets, the time and the budget, what sorts of other types of noise that may interact with our measurements we could have, the access, and then we look at the benefits. We can have extensive 2-dimensional and 3-dimensional maps as opposed to 1D drilling. We can have large continuous aerial coverage, and of course that comes with the advantage that is non-intrusive. We can access and we can go everywhere. It's fast and efficient, and it's, as you just saw, it's cost effective. And basically geophysics, it's engineering geophysics, is to be able to see things underneath things without the need of making a hole. And then we move on to the hole. So it also helps us to, if we do them early, to design the future intrusive site investigations. So if you have an interest in any of those types of disciplines we offer, you can get in touch with Costello recruitment at careers@coco.co.nz, And I will pass again to Aidan to do an epilogue, if you like, of today's presentation, give you a little bit of some insight about how we are doing with our social side of things. Aidan?
Yeah, folks, no, it's all very heavy there for quite a bit, just in regards to technical engineering and everything that goes with it, I suppose. But I suppose this is the part of the presentation where I tell you just how great it is to be part of the Costello team. But no, all joking aside, look, I think maybe the best way to do that is maybe just give you an idea of my story with the company. I actually started out in New Zealand working for another consultancy in town. It was quite a major player and quite a big consultancy. But when I was there, I was actually living with my housemate was an Irish fella that was working in Costello, and he was moving back home into the motherland, I suppose. And he had no real skin in the game, I suppose. And I said, look, it's a good company, it's a good place to work. I think you could maybe check it out. And so it was essentially, he said there's obviously going to be a position opening whenever I leave. And I think, if he said if he wasn't leaving, he definitely wouldn't be moving. So it was essentially just because of that, I jumped on board and came to speak to Costello. And since then, I haven't really looked back. And that was now nearly 6 years ago. I suppose everything that Nick's been talking about there today, they really do kind of practice what they preach in that regard. I jumped on and straight away. There was a obvious focus on professional development, nothing that was too severe where you thought you were being pressured into it or anything, but it was definitely a focus to, I suppose, help you along with your career. And straight away, as opposed to where maybe I was working before, I found myself in Costello literally from the first day I joined working directly with the director of the company. Just because that specific job that I was on, he was involved with, and that was it. And it's kind of, despite the company being that size with, I suppose, 60 plus employees, it's still at its core is still very much a family-run business, and everybody's very accessible to speak to and consult with and all of that. But I suppose just from the pictures you can see there, we are very active in what we do and how we get along with everyone. There's a very, I suppose, conscious effort to make sure that there is a good work-life balance and a good culture within the company. There's been a host of different various activities that we've carried out throughout the year. We're actually just back from Whangarei, and it's, I suppose, as I say about that family-run business. While we're all over the country in that regard, there's definitely a focus on getting that company or countrywide company together as much as we can, despite COVID and despite everything that goes along with it. And so, we're definitely quite a close-knit bunch. And besides all that too as well, rather than just, I suppose, the big events that we all head away off to, perhaps there's Mount Hutt and all the rest of it, adventure parks and things. The thing is, I suppose, rather than those big events that happen maybe twice, 3 times a year, it's more about the day-to-day for me. I count myself as a bit of a philosophical being, I suppose, and I think there's a need for a sense of purpose in your life and have a bit of pride in your job and stuff. And so I've definitely found that Costello, to be honest. You have a chance to do something that actually affects big change, I suppose, and you see those things happening in the environment around you. And I suppose the best compliment I can pay the company is that on a Sunday evening there or a Monday morning, I'm definitely not dreading going into work. So while I suppose that's a low benchmark, it's actually maybe not that low whenever you consider maybe everybody else. It's definitely a fun place to work. And as I say, I wouldn't be here, I suppose, 6 years later on the other side of the world as it is for me, if I wasn't enjoying it. And it's given me every opportunity, I suppose. So that's just a run through, I suppose, of where I've been with the company and my experience. And I know plenty of others too that have had the same experience too as well. But I'm conscious we've taken up enough of your time on a Wednesday afternoon, and even all those maybe that are tuning in a wee bit later. So I'll wrap it up at that. I think there's a bit of a question and answer session planned too as well, in case anybody does have any questions. But yeah, Bella, feel free to jump in and fire any questions our way if there are any indeed.
I don't think I've received any questions in the chat, but there was a message, someone saying that they'd enjoyed the presentation, but they had to pop off a bit early. But if anyone who's listening has any questions about the company.
I'm sure people are keen to jump away off on a Wednesday evening.
Yeah. Anyway, thank you for the great presentation. It was really interesting and I definitely learned a lot. And yeah, I hope everyone enjoyed it.
No problem, folks.
Thank you very much.
Cheers now.
Thank you very much, everyone.
Thanks, everyone.